So we've done a lot of factoring. So now we're going to use that factoring for something useful. Okay? Solving equation. All right. So it's going to be a mix of all the factoring that we've seen. Solving equations by factoring hinges on our zero factor property. I refer to it as zero product property. You'll see it both ways. I prefer product property because I like a little alliteration in my life. Just has a better flow to it. Just know if I say zero product property, this is what I'm talking about. Okay, zero factor property. And what it hinges on is the idea that if I'm multiplying a bunch of stuff together, if it equals 0, then at least one of those things has to be 0. Okay? Anything outside of that, it doesn't work. So if I have a number, Ellie, pick a number for me. 5. If I have 5 and I multiply it by something else and it equals 0, what does that number have to be? 0. That's what the zero factor property says. That if I'm multiplying a bunch of things together and their product is 0, then at least one of those things has to be 0. Okay? It's the only way for that to happen. So when I have something that's factored, I've got two factors here, factor A times factor B, and their product is 0, then at least one of those things has to be 0. So what we're going to do is we're going to say, okay, well, what value of x would make my first factor 0, and then what value of x would make my second factor 0. So I just have to check and see and solve. So I can set both of my factors equal to 0, and then solve for x to get my two solutions. Okay, the two values of x that would cause this equation to be 0. All right, so now we just got to go back to solving our equations. 8x plus 3 equals 0. How do I solve for my x? Subtract 3. And then? Easy enough? Okay. 2x plus 1 equals 0. Subtract 1. Divide by 2. My values of x are negative 3/8 and negative 1/2. Those are the two values that will make this equation true, because either of those will make one of these equal 0. And if I multiply anything by 0, I get 0. Okie dokie? Alright, so now that was already factored. So that was kind of easier, less work for us. Most of the time it's not going to be factored. We have to factor it. Okay? So there's a general idea that we need to start with a quadratic in standard form. So if we don't have a quadratic in standard form, we need to get it to standard form. Okay? Basically, everything on one side, set it equal to 0. That's going to be our standard form. So that's our goal, is to get our equation standard form. From there, we can factor, then zero factor property, then solve for x. So that's kind of this flow of our work. Write in standard form, everything on one side, set equal to 0, factor it by any of the myriad methods we have to factor, then we can use our zero factor property to solve for our solutions. And then it's always a good idea to check. This is more important when you get into like rational equations and things like that, but sometimes we'll get extraneous answers, not so much in the beginning. Okay, but checking always helps. All right, so step 1, is it in standard form? It's not in standard form because it's not set equal to 0. So how do I get it set equal to 0? Subtract 4. So I subtract 4 from both sides, and I get my 3x squared minus x minus 4 equals 0. Okay? Step 2, factor. What multiplies to give me negative 12 but adds to give me negative 1? What multiplies to give me negative 12 but adds to give me negative 1? Because I need to factor it now. Negative 4 and 3. So I can use my grouping. Okay? So negative 4 and positive 3. So now I can do my factor by grouping. Get x plus 1, negative 4, x plus 1. So what are my factors going to be? Using this grouping. What's my last step? Good. 3x minus 4. Okay? So I've got factored. Now we want to use our zero factor property, which says I take both of those and and do what? Set them to 0. X plus 1 equals 0, and 3x minus 4 equals to 0. Now that it's set equal to 0, I can go ahead and I can solve. Okay? X equals -1. And then we're going to add 4 and divide by 3. So those are my two values of x, -1 and 4/3. Two solutions. How we feeling? So when I split my negative x into 3x plus and minus, okay, now I have factor by grouping. I have like terms in these sets here and here. So my GCF for the first two is 3x, so I factored that out. That left me with x plus 1. Over here, my GCF is -4. That leaves me with x plus 1. And so then x plus 1 is now the greatest common factor of those two terms. So that's one of the factors. What's left is the other. All right, B. Is that in standard form? Yeah. Okay, so I don't have to write in standard form. Step 1 is done. You should have alarm bells going off. What might this be? Might be a perfect square. I got a perfect square. It might be a perfect square trinomial. How do I check? So I got 4m, and I got 3. Okay, before I factor, I need to check. So what am I going to do with those? Multiply them, and then double it. That gives me 24. So then, yes, it is a perfect square trinomial. Okay, so when I finish factoring it, it becomes what? Good. Okay, so I got my perfect square trinomial. It's factored. Remember that when you have something squared, it's just multiplied by itself. So we could write it out and see that, hey, I've got two factors. Okay, zero factor property lets me write them set equal to 0. Do I need to bother solving both of those? No, because they're going to be the same. Okay, so we just solve. What's m going to be? -3/4. Because I ended up with a perfect square trinomial, this time I only have one solution. Last year I had 2, this time I have 1. Sometimes I won't have any. Those won't be factorable, and those are a whole different situation. So most of the time when we're factoring, when we're solving equations, the possible number of answers is either 2, 1, or none. All right, depending on the quadratic that we have. And it's based on the way the graph looks, and we'll cover more of that when we move into our quadratics chapter. And we'll spend more time looking at the features of quadratic graphs and what the solutions actually mean. These aren't just like values of variables for the sake of it. They have a very important part with graphs of quadratics and interpreting them. So that's important that we can find those and identify what they mean. C, standard form? Kind of. Is it set equal to 0? Yeah. We're missing a term though, okay? But I can still factor it. So now I just have to think of a different way. How can I factor this? Factor out my GCF. So I'm left with P times P plus 12. So is it completely factored? Yeah. So set both factors equal to 0. One of my factors is P. The other one is P plus 12. Well, that one's already solved for us. That was nice and easy. Convenient. What's the other value of P going to be? -12. So P equals 0 and -12. 0 is an answer. 0 is allowed. All right. Standard form? How can I factor it? Factor out 5. So I'm left with x squared minus what? So if that's x squared minus 16, what does that mean? Difference of squares. Okay, so I got it. Now I can factor my difference of squares. So x squared minus 16 factors to be what? Okay, plus and minus. Is it all completely factored now? Yeah. So now I have three factors. I've got A times B times C, all equals 0. So I need to set A equal to 0, B equal to 0, C equal to 0. So 5 equals 0, x plus 4 equals 0, x minus 4 equals 0. Now when I look at this first one, does 5 equal 0? No. So that's extraneous. We can ignore that. It's not going to do anything. There's no variable to solve for here, so that's just kind of a byproduct of our factoring process. We had to factor the 5 out so that I could factor my difference of squares, but after that, it doesn't do me any good. So then I can solve both of those values of x. So what are my two values of x going to be? Good. We got positive and a negative 4. Lots of different factoring methods all looped in together. Sometimes we'll have a combination. Especially with the special cases, love to put greatest common factors in with special case polynomials. Okay, get that kind of that double loop there. Standard form? No. Okay. So these are partially factored, but because I have the other terms on the other side, I have to multiply these out again. I can't leave them factored because I can't combine everything into one term until it's completely factored. Okay? So I have to expand these out. A squared, negative 2a, positive 6a, negative 12. We can go ahead and simplify a little bit on the right side. 2 plus negative 10. Okay, so I've got negative 8 plus a. Combine like terms on the left. Negative 2 and positive 6. Say again. 4a minus 12. Negative 8 plus a. Now I need to get everything on the same side. Okay. Word of advice. Sometimes when we're writing things in standard form, we may have our squared term show up more than once. We may have it on both sides. Okay? Or it may be negative. You want to make sure that your leading coefficient is positive. So if it's negative, you're going to want to move everything from one side to the other so that your leading coefficient becomes positive. Okay? Remember, keep that in mind. You want your leading coefficient to be positive, so manipulate your equation in a manner that makes sure that your squared term is positive. Okay? That's really important. It just makes factoring a lot easier, and you're less likely to make mistakes. Okay? So I want to move negative 8 and a to the other side, so what do? Subtract a, and what else? Add 8. Okay? A squared plus 3a minus 4 equals 0. Okay, nice easy trinomial to factor. What are my factors going to be? Negative 1, positive 4. Okay, negative 1 times 4 gives me negative 4. Negative 1 plus 4 gives me positive 3. 0 factor. A equals 1 and negative 4. All right, and that's where I'm going to stop today.